The final session. And we have lightning talks. So anyone who's presenting a lightning talk, I've already told you to move to the front of the room. Oh, thanks, Chan. The time limit is going to be 5 minutes. It is going to be strictly enforced by Chan here with his mobile phone stopwatch. And first up, we have David Lay speaking on e-voting.
I don't think this one's e-voting.
No, that's not it. Wrong one.
That one. No.
No, it's you download. It's on the desktop.
Did I? No, it wasn't.
Where did you download it to?
No. It was a Google Docs.
It wasn't.
Yeah, it was. It was a Google Docs. One second.
That one.
No, that's
not a Google.
That's not the one we can do.
No, the other. No, they're both.
Both Dropbox. Okay.
Sorry about this.
Where did I download it to? Where's your downloads go to?
They go into download. And it's
I'm
not.
talking up there.
Where?
Okay, that's
We will start the time limit after we manage to download this, because it turns out that we're just incompetent.
Just open it again. Go with that.
Are you ready?
I am ready. Official stopwatch is ready.
Okay, David Lay on e-voting.
Okay.
And start.
Okay.
Speak to the mic.
So, can you hear me right? Okay. So, because I'm doing a bachelor degree in IT network security, one of the subject is e-commerce and e-voting, or e-commerce and e-governance security. So, in particular, we had to do a group assignment, so I choose e-voting. So as you can see here, e-voting. All right, so why do I choose e-voting? Because it's part of being a e-government technology, and so in the overview we'll talk about what is e-voting, how does it work, the criteria for it, regulation, where could it apply, and security. So first of all, what is e-voting? Everyone knows what voting is, compulsory, so everyone should be. Electronically, everybody should be able to vote. Unless they don't know how to vote, they make a donkey vote. Okay, so how does it work? Okay, I designed a use case diagram. Hopefully you can all read it. If you don't know, tough luck. Okay, so because we have enforced compulsory voting that you have to rock up to the site and do the vote, it would be far more better if you make it electronically and programmable, where every voter can interpret their language and then vote what they want. So see the use case diagram. Then, according to the network, because I'm doing network security, and this will be a layer 3 switch, which will connect to every single polling booth. From the polling booth, we'll connect to the cloud, and the cloud will have a SSL or VPN IPsec tunnel to the actual server for a storage to database. So, real life example, in Brazil, they have electronic voting already system set up, but we're not using it in Australia. Why? First of all, it costs too much, and buying a lot of equipment for the amount of polling booths in Australia, it's going to cost too much. Okay, so criteria. First of all, system integrity is the most important part, followed by data integrity and reliability. Then, voter anonymity and data confidentiality, operator authentication, system disclosability, system availability, system reliability, interface usability, documentation and assurance, personnel integrity, system accountability, and therefore we also anticipate for regulation for e-voting. Okay, so we have to comply to ISO 27001. We're going to use the NSIT SP 800-88 magnetic swipe card data erasure technology to secure erase all the data that's inside the magnetic card. Commonwealth Electoral Act, of course. The Privacy Act 1988, the Privacy of Personal Information Privacy Protection Act, 1998 in New South Wales, and the AEC. So, also the AEC for the AEC version of the New South Wales. Okay, so where does it apply? It's applied everywhere, at least where possible, but because voting does come to fail in terms of technology, there's a website that's been failed in terms of history, where you can find them. And therefore, we're also anti-privacy security, the risk. Such risks involve, as you can see on the table here, we have Trojan horse, well, it depends on where you make it from, unauthorized personnel, lack of compliance, voting fraud, infrastructure failure, denial of service, the common one for saying. So countermeasures, of course, we build redundancy. So you have, as you can see, that this threat table actually correlate back to the previous risk table that I've identified for you guys. And any question? Yep.
What university do you go to study information security?
Bachelor IT Network Security.
What uni is that though?
You become a network security analyst or a pen tester.
University.
It's the Tech New South Wales.
Oh, okay, awesome, thanks.
Sorry.
UT doesn't offer network security as like a specific
It's a brand new course. It's a brand new course. That's all. Any other question?
And 5 minutes. Please step away from the mic, David.
Yeah, I'm trying to make it quick. Of course.
Who's up next?
So next up, we have
Ari Oldman, Robert Quinn.
Ari Oldman and Robbie Quinn presenting on the importance of a sense of community in a digital environment.
Which is not that. Oh, this one. Yes. Okay. If you set it up, go ahead. Or download it.
I'll do.
Ready to go? No.
It'll
Be fine. All right, well, I'm probably the least qualified person in this conference. I mean, I'm not doing a software engineering degree, I'm not doing a computer science degree, I'm not actually doing a degree. I'm currently in high school. I just kind of came to this conference out of interest, really, see the uni, see what the field was like, and it's been really interesting, so I'd firstly like to thank everyone for letting me come here. One thing I did think I might be qualified to talk about, though, was, as you've probably read on the screen by now, the importance of a sense of community in a digital environment. And I was going to do this talk with my colleague Ari over there, but he's gotten a bit of a cold and didn't want to talk. So, just me. Okay, I'll just manually scroll down. We run a small game server hosting community based in Australia. We've got players from Sydney, Brisbane, Tasmania, New Zealand, Singapore, all around the Asia-Pacific region, really. We run servers for a lot of games, really, very teenager-type games. And we currently have a group of 179 members on our site. And importantly, we are 100% community funded. And I kind of want to talk today about how we got to community funding and ways which I think help people get community funding. So really what we needed to promote was this idea of selling nothing. So we took inspiration from microtransaction and free-to-play video games like Team Fortress 2 and the very popular Japanese MMORPGs that are on the market at the moment, where you essentially pay for nothing and they make lots and lots of money. So anyone can play these games, but there are VIPs, which have more community-based power, and you can get cosmetic upgrades and get the end-game content a little earlier, avoiding the grind, which is the majority of the gameplay, which kind of led to an even bigger dilemma, which was how on earth do you sell upgrades that are so minor and insignificant. So we had a lot of talks on the matter. This is from our official webcomic, which totally isn't made by me, before you criticize the art style. Bit subliminal. But then we came to the conclusion that the best way of doing it was to launch a website, and from that start an actual community. Rather than just a bunch of disjointed servers, we would make a community of a family of game servers, I suppose. So it's really important, this idea to me of a sense of community, because originally it was very hard for us to kind of stay in the black, get enough donations, because obviously we're 16, we are unemployed, so the only way we could get money was to whinge to our parents, which only goes so far, so we really needed community funding. So in, that's supposed to say May, we launched the Game Redacted website and convinced all of the regulars on the servers to actually join us through incentives to get them to join. Eventually, our community grew, and people that didn't always play on the same servers together started communicating, and a community started growing. And as you can see on this very statistically, lazily made graph, I'm not a statistician, so I'm not going to try and analyze it, but once the website was launched, things seemed to go up. That's my very technical analysis. This also had an unintended side effect of a real autonomy within the kind of community. Because we talked to the community and we played games with the community, people didn't just think of us as owners, they thought of us as friends. And this kind of also got rid of the real formal hierarchical structure, rather than just us being the owners, administrators being the administrators, and so on. Everyone was just playing games together, which was quite useful because then it meant that people would do our job for us. We wouldn't pay them, and yet they'd sit there doing hours and hours of work. It was great. Just great. We actually get lots of people applying to do our job for us a day, which, I mean, that seems like the perfect business model to me. So just to wrap up, since I'm running pretty close to the time limit. Although this is a pretty specific example of a game server community, I think it does have a bit of universal relevance within the software kind of computing world, because I feel like community is a very important part of selling software. If you play Gary's mod, feel free to check us out for our servers, because I need to fit in a bit of shameless self-advertisement. If you want to do my job for me, please do. Thank you.
Who's up next?
Jonathan
Francie?
Yes, Jonathan Francie on esoteric programming languages.
USB? Isn't it on here?
It may also be.
What's it called?
I think the lightning source.
What's it called?
It's on the USB. It's on the USB.
Okay.
Several different formats. Do whatever you want, just whatever format.
Come on. No.
Disappointing. There we go.
There we are. This one? No,
We did
which
it.
one? Which one?
Any of them.
Any.
The open button.
Okay. And the phone. And your time starts now.
Good afternoon, everyone. I'm here to talk to you about a little hobby of mine, something I quite enjoy, apart from apparently organising conferences, and which I also believe is the future of computing, and that is esoteric programming languages. For those of you not familiar with this fascinating facet of computer science, esoteric programming languages target less usability or ability to write large scalable programs. They more go for being incredibly frustrating or novel or just really weird, and I hope to give you some good concrete examples of that today. First up, oh dear, Microsoft has messed up the fonts for me. If the ordinary keys on your keyboard, the traditional letters and numbers, are getting far too worn to use, try a language that uses 8 symbols, none of them particularly sensible. As you can see here, we've got some source code there. That's a Hello World program, I believe. Feel free to try running it. You can get interpreters for this language, which I can't name in full at the moment, from many places on the internet. Some of them written in the language themselves, just because that's a really interesting challenge to set yourself. It's write-only language for most of the time. Don't expect any great degree of refactoring to be able to go into any code you write in this language, but a great challenge in working in a novel environment. We've also got an esoteric programming language that only works some of the time, and that's called Java 2K. Built-in functions only have a 90% chance of succeeding, so I hope you're feeling lucky when you run that executable. It also uses a base 11 number system because that's close to 10 and should work more or less the same way. The extra digit is a space, so hooray for readability. Speaking of spaces, here's a language consisting entirely of whitespace. 3 different whitespace characters. You can tell that something is a comment in this language because you can see it. I'm afraid, guys, this will not work very well for printed out assignment submissions, so if your assignment says language to be chosen by the student, probably still stay away from this one. Piet is a particularly graphic esoteric programming language. Here we have Hello World. Different instructions in this language are defined as transitions between hues and different shades. It's a very visual language, as you can see, and I believe just goes a step further in the programming as an art particular sphere of things. There are a number of other ones, and I highly recommend getting out there and looking at the huge array of things. Chef is a programming language where your programs will look like recipes. Really makes you hungry, though, so make sure you've got snacks available while you're coding. We've also got Shakespeare, where all your programs look like plays, and a particularly novel one to finish up with Malbolge. Now, Malbolge is designed to be incredibly difficult to program in. The first Malbolge program was written 2 years after the creation of the language. That's a fair while. It wasn't even written by a human. They had to get a Lisp program to search for something that might actually run in this language. So if you're looking for a real challenge, then give this one a shot. There are so many other esoteric programming languages out there. I'd love to detail them more, but time is ticking away. However, I highly recommend visiting esolangs.org, where you can find your own specific one, or you can make up your own. In this particular sphere of computing, anything goes. You choose the rules. The power is in your hands. Esoteric programming languages are great to learn. They really build character. Not only that, they have a few very interesting uses in computer science, proving various theorems about the nature of programming languages, things like brain thing, with only 8 different operations are a lot easier to work with mathematically than, say, Java or Python. And they're just good fun. They're a challenge. They get you to think in new and interesting ways. So go out and find one and learn to code in an esoteric programming language. Thank you.
Up next, we have Martin Henschke with Evolution of Programming Pedagogy. That's how you pronounce it, maybe, probably.
Okay.
How do I operate this thing?
I don't know. You tell me.
Oh. Thank you. Can I use YouTube? Is that going to work?
Probably, yeah. Sure.
Okay, cool.
Anyway, your time starts now.
Okay, I can't believe I'm giving the serious talk. Hi, everyone. Right, my name's Martin Henschke, and I'm going to be talking to you about the evolution of programming pedagogy. So, in 1975, a guy called Edgar Dijkstra said that programming is one of the most difficult branches of applied mathematics. The poorer mathematicians had better remain pure mathematicians. That's how hard he thought programming was. In 2012, we can make Space Invaders in 5 minutes. Things have gotten better, they've gotten easier. There was a time where it was just the domain of very highly trained specialists, engineers, and mathematicians. Today, it's my nephew and my grandmother. Things are changing. Okay, learning to program is also changing a lot. I was at Interact 2013 just about 3 weeks ago, and there they were talking about an example where a course coordinator was essentially saying that using lecture slides, live programming tutorials, a course coordinator can give a course over the course of a semester. A student used Codecademy and sat at the back of one of his lectures. Once the coordinator had completed one lecture, the student had completed the entire semester. So at the moment, we are not teaching programming correctly. This is clear enough. At the moment, we're using the traditional model of programming teaching, and that is the Indiana Jones model of teaching. That is to say, we have a man standing at the front of the room talking about something that no one's really listening to. We have high-level theory, we have a limited amount of practice, you have your laptop in front of you, but really not everyone's using it properly or necessarily, and we have live coding, where a man will sit there, program, you watch, and apparently that teaches you something. Perhaps the better paradigm that we want to talk about is using something that's slightly more engaging. So we use a supervised model that uses guidance rather than instruction. We allow students to actually be given an environment where they can work without the constraints necessarily of a very, very strict or difficult environment, and we allow to promote creativity and interactivity. Thus, we can promote the way in which teaching sort of programming stuff works like that in a better context. Our platform for doing this experiment, see if this works or not, is using Minecraft, more specifically Computercraft, because why not? So, if you're not familiar with this particular program, written by a few very, very smart people, Dan200, Cloudy, and a few other people sort of involved in the process as well, essentially it allows you to place computers in Minecraft and program using Lua. Lua is a very, very basic language. It uses just sort of an English-style syntax. There are very, very few operators and sort of complicated instructions which make it much, much easier to use. So it's a really, really great platform for allowing people to sort of work them as well. So essentially, we created 3 interactive workshops. We crowdsourced our volunteers, so we had 14 to 18-year-old students. Most of them were male, but not entirely, who had no prior programming experience. We had 3 hours where essentially I was put in front of a room in Minecraft. They were put in front of a bunch of computers and interactive computers called turtles that we used as well. They were given simple computers, and they were just learning how to use basic iterations, conditionals, function calling, your core of standard programming logic and stuff like that as well. We did it online. Why not? It was fun. We did it using these things, turtles. If you can imagine, if you're familiar with Minecraft and you can imagine blocks, this is just a block that moves around and digs things. Sometimes it places things as well. It depends on what you want it to do. Some of the things that we actually made them do. So we created a huge series of various different exercises and interactive things that they were able to perform. So this was one example of one of the things they had to do. We had a turtle essentially placed that red block there. The turtle would then sort of traverse around these sort of coloured blocks of wool. They would look at each individual block, determine what that meant in terms of a sort of syntax that we built on this little key at the top here, and that would allow the turtle to sort of move around this environment. They would then rearrange that to make sure it works in different orientations and perform different goals and tasks. This was another one. Essentially, we put them in front of these, again, this huge array of machines that would then walk around and build castles. Essentially just teach them how to sort of use iteration, how to use recycling of code, and things like that. This was another one that allowed them to use sort of very, very basic logic where they were able to sort of interact with the system by powering this little circuit that moved along here and move the pistons back and forth to try and get the turtle from one side of the maze to the other. Cool series of exercises that students were allowed to do to try and get them a bit more interesting. And at the end of the whole experience, I wasn't able to get this done because I wrote these slides 5 minutes ago. We would give them 2 castles, we put them into 2 teams and ask them to blow each other up using TNT. It was great fun and a great way to sort of practice and use a really interactive and creative method of teaching programming. Crikey. All right, so we had 15 participants in each session. We ran 2 sessions with those where we had actual programmers or teachers present, invisible and stuff, and all students covered all the material by the end of each individual session. I have about, I'm sure I can do this. It'll be fun, it'll be fun. All right.
About 3 weeks ago, I had a crazy idea to run an online workshop using Computercraft to teach people how to program.
That's fine. Anyway, screw that. Can we teach programming better? Obviously we can. The old Indiana Jones paradigm is not working.
3 hours where I taught basic programming theory.
It was a cool video, trust me. The approach is still high theoretical. It requires a lot more trials, a lot more research, a lot more testing to make it work. But which would you rather in your first year of university? That's it. Thank you very much.
That's working real nice. Damn.
This one. And so it's Jed, wasn't it?
No,
Alec, okay.
Also, Buck's going to be one without slides, and he's going to have to go very, very quickly.
Yeah, just present one. And
Okay, we have Alec Langford on the Internet of Things. Also, we are running a bit behind schedule, so if you could keep them quicker than quick.
okay, ready? Your time starts now. Alec, run.
Hi everyone, I'm Alec. I'm currently I'm currently studying a Bachelor of Cybersecurity at Edith Cowan University. But I don't know if I'm finished it because, as my presentation might suggest, I'm incredibly lazy. But some of the things I wanted to talk about was why I love the Internet of Things. I'm so lazy, I don't like getting out of bed to turn off or on my light bulb. So earlier this year, I decided to look up the possibility of having a light bulb controlled via IP. Turns out, lifex.co, which was first available on Kickstarter, currently building a light bulb that is IPv4 and IPv6 enabled, which will allow me to turn my light on and off via my phone. It also has way more features than my current light bulb. I can dim it and it can change color, which is really cool. And they're going to build me an SDK for it, so I can make it via my phone. I could even make it via a web application, just for lols. ARM in your car. The Raspberry Pi came out just recently, and I've got a couple of them, and one of my current goals is to put a couple of Raspberry Pis in my car. I can run Chrome OS and Android OS on a Raspberry Pi and mount it in the boot somewhere and have a screen as my in-car navigation and in-car entertainment system. There's a cool Kickstarter at the moment which is going to notify your Pi when your car ignition is turned on and off so that you can safely shut down your Pi and start up your Pi within a reasonable time when your car ignition is triggered. So much wireless. There's lots of Wi-Fi stuff going on at the moment. Wi-Fi light bulbs, for example. Bluetooth 4 just came out. We've got Zigbee floating around. NFC, and there's a new cool one which I won't go into at the moment because I don't have enough time, which is Flutter, which was really well designed, has huge range of over 1 kilometre, and is also quite secure compared to the other ones. Wi-Fi everything. I look at something and like my light bulb and I go, why doesn't my light bulb have Wi-Fi? Turns out these guys on Kickstarter, SparkCore, have created an Arduino board with Wi-Fi. So you find something like a light bulb or a lamp or your old TV that's not quite a smart TV because you bought it just before the smart TV bubble. Buy one of those and screw Wi-Fi onto your TV. You can now control your TV via Wi-Fi. It's awesome. The one below it, the Fargo, is it's an Arduino board with a whole bunch of relays, which allow you to wire all the lights in your house to this one board and turn them on and off via Wi-Fi. Woo! Here's a couple of examples of ones that they used for the Spark, which was a Twitter fridge magnet. I heard a really good story just the other day from one of the guys here at ANU who had an Arduino board attached to a door sensor, created a Twitter account for the door sensor, and had the door sensor updating Twitter on the status of whether it was opened or closed.
It doesn't work anymore.
Well, fix it. So, I don't know why you would, but a Twitter fridge magnet, which is pretty cool. Wireless motion detector, wireless doorbells, wireless sensors on my doors. It's all awesome. Conclusion. The Internet of Things will start with the people in IT. Buy... You're telling me to stop? No. Buy a Wi-Fi Spark and a whole bunch of other Wi-Fi, Bluetooth, Arduino stuff, and put Wi-Fi in everything. I'm going to do an expanded talk on hacking Wi-Fi, hacking the network of things next year, and I hope to hear some good stories of stuff that people have put Wi-Fi in.
Okay, we have Jed Barber presenting on why Linux is a Turbo OS.
And your time starts now, Jed.
Well, firstly, this is totally not a troll. I can assure you of that. Have to scroll. Okay, well. Yes, I'm being completely serious, and, well, the entire point of this is, well, Linux is actually a terrible operating system, and the reason being is there's a huge list of features which would be really great to have in Linux. They would enable us to do really interesting things, but, well, we don't have them, and the really annoying thing is that they're old features. They're decades old. They've been researched. They've been put into research operating systems, but, well, like I said, we don't have them. Linux has chosen to take simpler systems, starting with... everything is a file, except no, Linux, no, it's not. This, in fact, was improved and done properly in Plan 9 from Bell Labs. Perhaps some of you have heard of it. And as a consequence of this, pretty much everything in Plan 9 is, well, it's completely network transparent. If you want to run a program which uses a device on an old computer, you can just mount the file system from that computer and use the device files quite simply. On Linux, this is kind of sort of possible, but some file systems, it's really, really tricky. The SSH FS doesn't quite work this way. And of course, Plan 9 was developed in the 1980s. There's open source release 2000, 2002. It's old stuff. There is older. In the windowing system, it's I can't even pronounce this. Compositing window system was first done in 1985. It's still gradually coming into X11. So I believe the first windowing systems that were like this in X11 was like around mid-2000s or thereabouts. X11 itself is a violation of the entire everything is a file thing. Everything is a file in Plan 9 was done properly, and as a consequence, the windowing system there, it is done entirely via files. As also a consequence of that, although it's not particularly useful, you can run Plan 9's windowing system within itself. Okay. Security. Suppose you have a malicious program and you download and you run it. What's stopping it from deleting all your little personal data? That's normally set to be accessible by you because, well, you want to do that. With access control lists, as in Linux, which are only done by the world, group, and by user, it's not really easy to restrict things like that. Capabilities, on the other hand, are basically the opposite of access control lists, and it's basically each process has a list of things which it's allowed to do, as opposed to lists of processes which are allowed to mess with something. Capabilities have been known about and been implemented for decades. In the 1970s, in particular, KeekOS is probably one of the more extensive ones, and Eros was a successor of that and is actually implemented on things like x86. Transparent persistence. Autosave for the entire operating system. Imagine an operating system where if the power is accidentally cut out, or if you turn the computer off, you can just turn it back on again, like 15, 30 seconds. Back where he started, lost maybe a minute or two of work. This was available all the way back in Multics. It predates Unix itself, never mind Linux. It's also in KeekOS and Eros. KeekOS, they used to advertise it by having it running on a computer. They just pull the plug, literally, and then turn it back on. Keep going. Let's see, where are we? File system. Now this has a couple of things when I can actually get there. Versioning file systems would fix the whole accidental deletion thing and overwriting things accidentally. Everyone who uses Linux has probably accidentally RM something and oh crap, can't get it back. Versioning file systems, you could easily get it back. Log structured file systems, mechanical hard drives. The seek times tend to dominate trying to write things or read things because things are scattered throughout the actual hard drive. Log structured file systems, basically you record changes in a sequential fashion along the hard drive, and this allows you to group writes into basically one long write, and as everyone who's actually looked at mechanical hard drives probably knows, one long write goes a hell of a lot faster than right here, go over here, right here, right here, right here. Set layout file systems. Instead of a tree structure, you basically use sets. This is the sort of thing which was allegedly going to be available in the Windows Longhorn file system, whatever the hell that was. I can't remember exactly how old this idea is. I didn't have time to look up because I literally did this 5 minutes ago.
10, 9.
Fuck you. Crap, sorry. 6. Okay, scheduling, adaptive scheduling, kernel 992. 1. Fine, shut up.
1. And away from the microphone, Jed. Hands off the keyboard. Hands off the keyboard. No!
Okay, next up we have Bucks Legolas presenting on his GEM project, and he doesn't have slides, and he also has only 3 minutes.
Fuck. Countdown.
Ladies and gentlemen, you know what we do a lot in physics? We write equations down, and then we declare things in different equations equal to each other. I can't do this, I didn't know I was doing this.
Just go.
So, my proposal is for a graphical equation manipulator which allows you to write down equations from a predefined library of physics equations, then specify it by dragging between variables which ones are equal to each other, then double-clicking on a variable to have it automatically output, an expression for that variable. Then you can write in numerical values which possibly include uncertainties, and this enables you to, do enormous amounts of bits of physics enormously easy. It's a current physics project of mine. I have a running prototype, but you should come talk to me personally about it so I can show you. Thank you very much. You should all use my software.
And next up, we have a presentation from Matthew Rossi, Eloise Ducky McDonald-Meyer, and Vivian Lee, and myself.
And your time starts. Put it up, quick. Quick.
We're having an open discussion in front of people for 5 minutes.
Your time starts.
Sounds wonderful.
Now, there. Okay.
Yeah. So, Matthew here is the president of CISA, the Computing and Information Systems Students Association, University of Melbourne. I'm the president of the ANU CSSA. Ducky here is the co-pres of the UTAS Computing Society, and Vivian is running for president of the Sydney Uni IT Society.
Vote for her if you're in suits.
Yep, do that.
Or just become a member.
Anyway, so we were, talking over the course of this weekend, as one does at conferences, and we came up with, we kind of thought more events like this, events where we can get people together from interstate.
Intercollegiate LOL tournaments. Thank you.
Okay, we're going to have to agree to disagree on that one.
We can play Dota too if you want.
Okay. Anyway, we're just winging it here, as you can probably tell.
Open discussion.
So basically the idea is to set up a organisation that acts as a sort of a federal body that computing student clubs around the country from universities affiliate to. And this body is intended to do things such as run CompCon and sort of better facilitate links between various student clubs to sort of assist the work of existing clubs and help form new clubs and find ways to sort of create events and other things that would help benefit computing students across the country.
We haven't decided on the name yet.
Suggestions. Twitter. We have a hashtag for CompCon. Just tweet it under that.
Yeah. Or, if you're at all interested in participating in this project, or say interested in starting a computing club at your university, or you're involved in an exec at your university's computing club,
member, come talk to us.
Come talk to us after this closing session. Do we have anything else to say?
Do you want to go back to your unis and tell your exec how great CompCon was?
Yes.
So that they'll come and join us and be on board next year and the following year.
Yeah. Please do.
And with the name, could we try to think of something where the acronym makes like a word?
Yes.
Yeah, that would be
like that.
Can we also try and think of something where the acronym makes a word that we can actually put on public documents? There was a lot of brainstorming going on the other night about this.
Federated Union of Computing Society.
I veto that.
We have APS already.
Anyway, watch this space. If you're interested in helping us out with this, please come and talk to us. Thank you.
So now we come to the real reason that I decided to organise CompCon. I am unveiling my project. Okay? So I've been working on a research project for the past 6 months, and I want to tell you guys about it. What I wanted to do was use big data to my advantage. So I've had a look at how Facebook does things, and they've gotten very popular, but to tell the truth, they're a bit long in the tooth. I used a Web 2.0 front end to optimize the behavior of the UI and take advantage of the synergy between its on-demand services. I don't just want to focus on the platform, it's about user engagement. I seek to innovate the mobile-enabled platforms by using a robust, client-centric codebase. I want to strategize the convergence between crowdsourcing and next-gen data mining. What I want is a viral, innovative new platform. I want to solve the issues with the current dynamic HTML5 implementation of competitors. I've done a lot of brainstorming, and I aim for it to be interactive without being disruptive. I hope that Mishmash will create a buzz. Feel free to drop me a word if you have anything to say. Thank you. Is there a Kickstarter? I haven't set up a Kickstarter yet. Also, just a note on the name, that is the journal that Jabberwocky was published in. Lewis Carroll's Jabberwocky. Cool. Now let's actually get on to closing.
Very, very quickly.
It's already open. Okay. Here we are. And F5. There we are. Cool.
Okay. Yes. Firstly, thank you. We have to go through this very, very quickly. So thank you to our awesome sponsors, our platinum sponsor, the Australian National University, for providing us with venue, money, and just support, general help. Particular thanks to the College of Engineering and Computer Science, Paul Malloy, Bindi Mamuni, Henry Gardner, quite a few other members of staff who have been really enthusiastic about this quite risky project. Our silver sponsors, National ICT Australia. As you can see, they've supplied us with quite a few speakers as well as funding. They are a great organisation. They are doing obviously great things with big data, bionic vision, optimization, all the stuff we've seen through their talks.
And if you enjoy what they do, please support them.
Please support them. They are in the process of trying to regain federal funding at the moment. Our other silver sponsor is the Australian Signals Directorate, the national agency responsible for information security and signals intelligence. If you have an interest in the security field, go talk to them. Our bronze sponsors, the ANU Students Association, has provided us with financial support, as well as Google, who has provided support for the Travel Scholarship Program. We've also received support from Linux Australia. They funded Eleanor Williams' travel all the way from Perth for the open source software development talk. So they have been fantastic. And none of this could have happened without the ANU Computer Science Students Association, where this idea kind of began.
Yep. Okay, and a big thank you to our volunteers. If you
can they get up
come up, we have Jan Zimmer, who will put his hand up at the back, right there.
Jan!
We have Nan San, who is somewhere. Oh, there she is. And Patrick Payton.
Magic Mobs.
Nicholas Magic Mobs. Micaiah Coe, who is our photographer. Huge thank you to all our speakers. We don't have many, if any. We have a few in the audience. But without them, this would not be possible.
Speakers are kind of important for conferences, it turns out. And we can't even fit them all on one slide. We've had so many. They've all been excellent. Thank you to all our speakers for their amazing support. And yeah, the rest of our organising committee. We've got Jonathan here, Chris over there, Buck, who you've just heard from, Lewin is somewhere, hey Lewin, and Abby is also over there. Without them, none of this could have happened. They've been a great help in getting all the organisation done. They've been fantastic. So, feedback. We will be sending out a feedback survey to all attendees shortly via email. Please check your email, watch out for it. Please fill it out. We really want feedback on what went well, what didn't, and what we can be improved for any suggestions for next time.
Be as honest as you can.
It'll be anonymous. We won't come down and find you and kill you or anything like that. Talk recordings will be available from the website, compcon.net.au, very shortly. Keep the social media going. Like our Facebook page, share it, tell people, your thoughts about it. The Twitter hashtag has been going off thanks to about 3 of us. Thank you, Claire and Caitlin and Ducky and a few others for keeping that going. Micaiah's photos will be going up onto interwebs quite shortly. If you don't want a photo uploaded or you want an already uploaded photo to be deleted, please come speak to us. We will arrange that.
So, travel scholars. If you are Melbourne people travelling by bus, you should not be here. Run. Sydney people, we will have delegates walking you. Not delegates. Sorry, people walking you to Jolimont at 2:30.
That's in 33 minutes.
That's in 33 minutes. Get ready. You'll go. Everyone should just meet somewhere outside CSIT. Brisbane people leaving for the airport 3 o'clock. Lewin will be driving you. So find Lewin somewhere outside CSIT. Melbourne people, same thing, 4 o'clock. And N101 will be open pretty soon for people wanting to pick up luggage.
What about locals?
Locals, you can find your own way home.
So, anyway, there's been one group of people who we've forgotten to thank so far, and you need 2 things for a conference. You need both speakers and delegates, so thank you all for coming. this idea was the idea of holding this conference was dreamed up a long time ago in a galaxy far, far away, by which we mean about October last year, over in the CSIT labs at 3 o'clock in the morning.
It's a lesson about the perils of staying up late and having crazy people around you.
You get signed up to do stupid things like this. Anyway. We we went into this, not knowing how we were going to get people to come, and we got people to come. And thank you all for coming.
It's just a worry, do we have enough money? Oh, we got money. Do we have enough speakers? Oh, we found speakers. Do we have delegates? And you guys have turned up, so it's all good. We ran it.
Thank you all for coming.
Thank you all. CompCon 2014?
Come talk to us about that. Anyway,
thank you all for coming.
That marks the end of the inaugural CompCon. So, yeah.
A massive round of applause for our organisers who
Yeah,